Welcome back to CRMONCE. If you have ever shipped a PowerApps solution that calls a custom ASP.NET Core API, you already know the pain of a Canvas app choking on an unhandled 500 error. Today we are going deep on advanced error handling strategies that turn messy server exceptions into structured, predictable JSON that PowerApps can actually reason about. We will build custom middleware, global exception filters, a proper error contract, and even show the PowerFX code that consumes it. This is not about slapping a try-catch around a controller action. This is about designing a contract between two very different runtimes so failures become graceful, user-friendly experiences. Let's frame the problem. Most tutorials stop at returning a 400 or 500 status code, but PowerApps needs more than a number to build a good user experience. A Canvas app calling a custom connector sees a raw HTTP response, and if that response is inconsistent, missing detail, or just an unhandled exception dump, your maker has to write brittle if statements against status codes alone. We need a standardized shape every single time, whether it is a validation failure, a database timeout, or an unexpected bug. We also need enough detail for logging and support, but not so much that we leak stack traces or connection strings to the client. Here is the big picture architecture we are building toward. A request leaves the Canvas app through a custom connector, hits our ASP.NET Core API, and instead of exceptions bubbling up uncontrolled, they pass through a centralized handling layer before anything reaches the client. That layer normalizes every exception type into the same JSON shape. The custom connector passes that JSON straight back to PowerFX, where our formulas parse it predictably. The key idea is that PowerApps never has to guess. Whether it is a validation error or a database timeout, the shape of the response is identical, only the content changes. That consistency is what makes error handling maintainable at scale. Zooming into the ASP.NET Core side, let's look at where exception handling actually lives in the middleware pipeline. Requests flow left to right through routing, authentication, and eventually your controller action. If an exception is thrown anywhere downstream, it needs to be caught before it hits the response writer. We place our custom exception handling middleware as early as possible, right after routing, so it wraps everything else in a try-catch boundary. This is different from filters, which operate inside the MVC action invocation pipeline. Understanding this distinction matters because middleware catches everything, including exceptions outside of MVC, while filters give us richer access to action context and model state. Let's write the middleware itself. We wrap the call to the next delegate in a try-catch, and on failure, we delegate to a handler that inspects the exception type and builds a problem details response. Notice we are not just catching system.exception and returning 500 for everything. We are pattern matching on exception type, so a validation exception becomes a 400, and something like a timeout exception representing a transient fault becomes a 503. This single choke point guarantees that no matter where in our API an exception originates, the client always receives the same predictable JSON shape with the correct status code attached. Middleware is great for catching everything, but sometimes we want tighter integration with the MVC pipeline, especially if we need access to model state or action arguments. That is where a global IException filter comes in. We implement onException, inspect the thrown exception, and set context.result to an object result carrying our problem details payload. Setting exception handled to true tells MVC we have fully processed the error, so it will not continue up the pipeline. We register this filter globally in program.cs, so every controller in the API automatically benefits without needing per action, try-catch blocks scattered throughout our code base. Why base all of this on problem details instead of inventing our own shape? Because problem details is an RFC standard already baked into ASP.NET Core, and it gives us a predictable set of fields including type, title, status, and detail. We extend it with custom properties like trace ID and errors to carry validation specifics. This means our error contract is not some bespoke invention only our team understands. It follows an industry convention that tooling, logging platforms, and even other client SDKs already expect. For PowerApps makers, That consistency means they can write one generic passing formula and reuse it across every API call in the app. Validation failures deserve special treatment because Power Apps often needs to highlight a specific field, not just show a generic message. We use fluent validations, validation exception, and convert it into a validation problem details object, grouping errors by property name into a dictionary. This gives us a payload where each field name maps to an array of error messages. On the Canvas app side, this means we can inspect errors.email or errors.phone number directly and set the border color or error text on that exact form control. This is the difference between a generic red banner and truly professional inline field validation in your app. Let's look at the actual JSON contract that leaves our API and lands in the custom connector response. Notice the shape is consistent regardless of the failure type. We always get type, title, status, and a trace ID for support correlation. When it is a validation failure specifically, we also get an errors object keyed by field name. This is the exact payload Power Apps will parse. If your team standardizes on this shape across every microservice, your Canvas app developers only ever need to learn one parsing pattern, dramatically reducing the amount of defensive PowerFX code needed in every single API call throughout your apps. Validation is only half the story. Transient faults like a momentary database timeout or a downstream service hiccup need retries rather than an immediate failure surface to the user. We use Poly, the resilience library, to wrap our outbound HTTP client calls with a retry policy using exponential backoff. If all retries are exhausted, that exception still flows into our middleware and gets mapped to a 503 transient fault problem details response. This tells the Canvas app explicitly that this is temporary and retriable, which is very different messaging than a permanent validation failure, and it should trigger a different notification pattern in PowerFX. One detail that separates amateur error handling from professional grade deployments is correlation. Every problem details response we generate includes a trace ID pulled from HTTP context.trace identifier. We log that same identifier server-side using structured logging, so when a user reports an issue in the Canvas app, support can search logs by that exact trace ID and immediately find the corresponding server-side exception, stack trace, and request payload. Without this, you are stuck asking users what time it happened and guessing. With it, triage takes seconds instead of hours, and it costs us almost nothing to implement since ASP.NET Core already generates these identifiers for free. Now let's flip to the Power Apps side and see how PowerFX actually consumes this contract. After calling our custom connector, we pass the response body as JSON and inspect the status field first. If it is 400, we know it is a validation failure, so we drill into the errors object and pull out the specific field message, in this case for email, and use it to set a label or notification. If it is anything else, particularly 503, we show a friendlier retry message instead. This single reusable pattern can wrap every API call in your app, giving makers a consistent, low-code way to handle failures. This is what it looks like from the end user's perspective. Instead of a cryptic connector failure screen or a raw JSON blob, the maker has built a clean inline error directly under the email field using the exact message our API returned. The user immediately understands what to fix without ever seeing a stack trace, a status code, or a trace ID. That technical detail still exists. It is just tucked away in your logs for support, not thrown in the user's face. This is the entire point of the architecture we built today. Precise structured errors on the back end, translating into calm, actionable guidance on the front end. Let's recap the strategy we walked through today. We centralized exception handling in middleware so nothing slips through uncaught. We layered in a global iException filter for MVC specific context. We standardized every response on problem details, extended with trace ID and field level errors. We treated validation failures and transient faults as fundamentally different categories requiring different user messaging. And we closed the loop with correlation IDs for fast support triage and clean power FX passing patterns that any maker on your team can reuse. If you are building serious Power Platform integrations, This pattern belongs in every API you ship. Subscribe to CRMONCE for more advanced Power Platform and .NET integration content, and drop your questions in the comments below.